I'm doing a series of videos reflecting on my recent trip to San Francisco, and not all of them have very much to do with San Francisco itself, but this one does, because after I'd been to a conference, I had a couple of days on my own, and the way I like to get to know a new city is to walk around. Well, I've been in San Francisco a couple of times before, but I've never had time to walk around the city, to find my way around, and I certainly did. In 2 days I walked miles around the city of San Francisco. And in the course of that walk, those walks, I went around parts of the city I'd never seen before. Washington Square, and came across a building that was on the map as the Cable Car Museum. And I learned about San Francisco cable cars. You will have be familiar with the cable cars in San Francisco from the movies that are set in San Francisco. What I hadn't realised was why they're called cable cars. And that's what I discovered at the Cable Car Museum. But it's not really a museum, it's actually a working building. It's the engine that drives the cable cars. And what I hadn't realised was that underneath the roads, the routes that the cable cars run on, there are cables under the road, so that you have a road surface, and then underneath there is a wire cable, and that wire cable is moving, so that the cable car itself, obviously not drawn to scale, but the cable car has a lever that drops down and fits down through a slit in the road and can grab that cable. And when it grabs the cable, the cable car moves along with the cable, and the driver pulls the lever in order to make the cable car grip the cable. Fascinating system. And the museum had the driving wheels, this marvellous Victorian period piece of engineering work with all that implies for the smell of hot oil and the heavy moving metal parts, all of the attraction of steam engines and paddle steamers and contemporary work, no longer driven by coal and steam, but driven by electric motors, but the system is basically the same. And this video now shows the wheels that move the cable under the streets. The cable cars move when the brakeman pulls on the brake. This is the exact opposite of the trolley problem in philosophy, the trolley problem of brakeman trying to slow the movement of the trolley car by pulling on the brake. In San Francisco, the brakeman pulls the brake in order to get the trolley car moving. I guess they have a brake for when they're going down the hills as well, but the motive power comes from gripping this cable under the road. And the system was initiated by a man called Andrew Smith Halliday, and he was a manufacturer of steel cables. So you might suspect that he had a vested interest in building cable cars as creating a custom base for his product that he was trying to sell. He was a man, I'd like to think, I mean I'm not sure, he had other he had other parts of his business venture, but here was a man who had a solution wire rope, and he was looking for problems that he could solve using wire rope, and he solved the problem of horses pulling heavy loads up and down the hills of San Francisco by applying his steel rope to the problem and getting the solution. But we have to be careful, and this was the reflection that I was having. Be cautious always of people who have a solution and are looking for a problem to fit it to. There's no reason why the cable cars need to be cable cars, except that the people of San Francisco have become attached to them, a sentimental attachment to the way they look and the way they run. When there was a proposal to replace the cable cars with ordinary buses in I think the 1950s or 1960s, there was uproar that the people of San Francisco wanted to keep their cable cars. So nowadays it's part of the tradition, that's part of the very character of San Francisco that has cable cars, but there's no real need for it. But when Smith Halliday was setting this up, he'd got the solution. Be cautious always of people who have solutions and are looking for problems. I was introduced to this idea that observation and decision making should be impersonal long ago, when I was about 11 years old. It's a feature of scientific method to distrust people who have a vested interest in a particular answer. And we were studying, it was a science class I was being taught, and we were looking at the expansion of gases when gases get hot. And I said to the teacher, and therefore to the whole class, that if you take a fairly empty milk bottle from the fridge, so there's a lot of cold air in the bottle, and in those days milk bottles had a metal cap that loosely fitted on the top, but would possibly be sealed with cream or milk residue around the edges. And I suggested that on occasion, if you've got the conditions would just happen to be right, that the air in the bottle would expand, and you'd be sitting at the table, say at breakfast, and there'd be a pop, and that lid would be pushed off by the air. It's kind of important that the seal be made around the edge, or the air would just leak out without popping the lid off, but every so often the lid would pop off. And so the teacher said, he'd never heard of such a thing before. Why didn't we, each of us, go home and experiment to see whether I was telling the truth? Well, that was fine. I had no objection to that. Let's see whether my idea is borne out in practice. And we came back a week later or 2 days later, however long it was, to the next lesson, and the teacher said, did anybody try this experiment out at home? And some of us raised our hands, and he said, did it work for anybody? And I raised my hand, and he said, I'm not interested in you, it had to work for you. And I was a little affronted, but thinking back on it now, less so, because if you've put forward a solution, you've got a kind of vested interest in it working. You've got a different perspective, you've got a presumption that it will work, whereas the people who test it carefully need to come to it with a presumption, a neutral presumption. It might work, it might not. They don't have a vested interest in it. And I'm always suspicious of people who have a solution they're going around hawking and depending on answering, whether it's the flipped classroom, the whatever fad is going on, the outcomes-based learning, whatever if the fad is, if it's just the words of a solution without being thought through carefully, don't trust it. And there's something about then the scientific method that I learned about when I was 11, that it's not that you can have hypotheses, you can have hunches. It's not that you can't have an emotional attachment to a particular outcome. If we didn't expect to make the world better, to contribute to knowledge, to prove people's understandings, we wouldn't bother to get up in the morning. It's because we believe we can do something and have a positive outcome that we do anything in the first place. But testing a hypothesis requires that neutrality of not being involved, and it's easier, not impossible to do it with your own thoughts, but it's easier to do it with other people's thoughts than with your own thoughts. So it's not, the scientific method is not, in my view, about complete objectivity. Subjectivity plays a part in anybody's motivation to do any study at all. Subjectivity is there, live with it, get used to it, but we're trying to be detached and have an effort towards, however imperfectly, towards standing in neutral observation and becoming more objective, but not, there is no such thing as complete objectivity. There's intersubjectivity. When 5 people get the experiment to work in a particular way, 1,000 people get to work in a particular way, becomes more supported by the evidence, but it's never absolutely proven. So what I'm saying to you is, be suspicious of an opinion that is too widely held or too fiercely argued by those who believe in it, and be prepared, even with your own ideas, to take a neutral stance, to try and see this experiment, see these phenomena through the eyes of other people, and not to be in a hurry to apply a solution just because it's the first or the most vigorously argued solution that is put to us.